All right, so weighted graphs and the traveling salesperson problem. So, sales directors for large companies are often required to visit regional offices in a number of different cities. Now, how can these visits be scheduled in the cheapest way possible? For example, if we have a sales director who lives in city A, and if we're looking at a graph, we'd be starting down here, and he's required to fly to regional offices in B, C, and D, and that's the other three offices. Other than starting and ending the trip in City A, there are no restrictions as to the order in which the other three are visited. So we could go A, B, C, D, and back to A, or we could go A, D, B, C, back to A. It doesn't matter which order we do that in. Now, the one-way fares between each of the four cities are given here in this table. A graph that models this information is shown in the also below here, what we've been talking about here. Now, the airfare between each of the cities is shown as a number on the respective edge. So, this is the amount it costs between A and B. This is how much it costs between A and C, and A and D, and A and or D and C, and C and B and D. And we can get that from our table here. So if we look at A, to go to B is 190. So that shows here A to B is 190. And then A to C is 124. And then A to C is 124. And so that's how we're able to draw from this table, we can draw this graph. Okay. So that's what we're going to look at. And so a graph whose edges have numbers attached to them is called a weighted graph. So this is a weighted graph here. Now, the numbers shown along the edges of a weighted graph are called the weights of the edge. So those are how much it weighs. And in this case, they're dollar amounts. And the figure below is an example of a completed weighted graph. Now, the edges of AB is 190, modeling $190 airfare from city A to city B. Now, the sales director needs to find the least expensive way to visit cities B, C, and D once, and then return home to A. Now, our goal is to find the Hamilton circuit with the lowest associated cost. So what we're going to do is we're going to use the weighted graph in the figure below to find the cost of the trip for the Hamilton circuit, A, C, B, D, A. So we're going to go this way. We're going to go A to C. So we're going to go down here, and then we're going to go up to B, and then we're going to go down to D, and then we're going to go back up to A. And so how are we going to do that? Well, we're just going to add up those sides. So we're going to take 124 plus, then we have 126 plus, then we have 155 plus, and then we have 157. And if we add all those together, that weighted graph is going to be $562. So that's going to be how much it costs to do the trip in that order, A, C, B, D, A. Okay. Now, what we'll do next in a little bit is we're going to do something called the brute force. So we'll stop there and then we'll come back with the brute force.